Hello all. So myself, Dr. Vemula Anand Reddy. I have done my graduation in civil engineering and masters in soil mechanics and foundation engineering from NIT Surat, Gujarat, and PhD in civil engineering from NIT Surat, Gujarat. So what is this engineering geology is dealing about? So most of the times in our daily life, we see granites, right, rocks, stones, different types of sandstones, different types of soil material, etc. So these all are related to some sort of soil science, which we are terming it as geology. So the application of this, the soil science that we can say in the infrastructure management or to build any civil engineering structures, civil engineer must have a clear idea of different types of rock formation or soil formation that is available underneath the ground. So these are the various types of rock formations basically that we basically encounter. They are igneous types of rocks, sedimentary types of rocks, and metamorphic type of rocks. So while we move more in detail in further sessions or in the classes, we can see in detail about these types of rocks. So this is another example, which is just a mixture of types of rocks. And this is the three types of formation: igneous rock, sedimentary rock, and also the metamorphic rock. And we can see few samples here how the different layers are formed here by, and the process is basically this is a sedimentary rock. Okay. Yeah, and we can see here different layers of rocks. So some are like plate shaped, and some rocks are like in bed shape, etc. And there are some clay sample, type of clay sample which is very hard, that is in plate shaped, has been compressed over a few years. So that's why we can see the plate shaped particles here, which is highly compressed. Mostly it might be the clay particles. And also there are the, again I wanted to highlight like a few of the igneous rocks, that is basalt rock, granite rock, gramine, rhyolite, dacite, etc. So now we need to know what is the outcome or the overview, that what are we going to learn in this entire course. So this course provides civil engineers and geologists with an overview of engineering geology. Engineering geology routinely deals with application of geological site characterization and the evaluation of geological and geotechnical conditions for the design, construction, operation, and maintenance of engineering structures. So this course is designed to provide a general background of geological considerations, identification, classification, and engineering properties of soil and rock. Additionally, geotechnical field exploration methods used in engineering geology will be covered. So the interest is to give the reader a basic understanding of some of the investigation and the classification methods of soil, rock when used as a construction material in the engineering application. So that is what I have told. So to for any foundation or for any foundational structure, geotechnical engineer or a foundation engineer or a foundation design engineer or a structural engineer must be known, well informed with the safe bearing capacity of the subsurface, so that he can plan for the depth of foundation and various dimensions of the foundation, whereas to understand the different types of foundations that had to be laid. So for that, the engineer must have a clear picture of what type of soil formation that is available underneath the foundation, or where the foundation bed is going to be constructed. So these are the various course objectives where we will be basically delivering, so that the students will achieve these particular objectives. So the process of formation of rocks, their classification and properties of minerals, the identification of different geological structures encountered in the nature, the different hazards such as earthquakes, landslides, etc., causes and their effects, the importance of geophysical and geological studies of sites for tunnels, dams, and reservoirs, etc. So these are the various objectives. The different hazards such as earthquakes, landslides, causes, and their effects. So in the northern region in India, most of the times we will be hearing that there is a big landslide. So for understanding the causes for the failure, to have some investigation, to understand what are the types of formation which caused for the failure, or to create an impact of an earthquake, their causes and their effects. So geology will be very very vital for understanding. These are the course outcomes, that is like relate the concepts of how minerals form, their uses for identifying the rock forming, classify the rocks using basic geological systems for selective construction material, interpret graphs and modes used in structural geology for demonstrating stress strain, tectonics, etc., relate the geological concepts and approaches of rock for engineering projects, and compare the past tectonic setting of an area for evaluation of current structures, and list out the design and construction procedure required for controlling the safety of rock behavior in the dam construction. So we can see the classification of rocks using basic geological systems for selective construction material. Relate the geological concept and approach of rock for engineering projects, which is very very essential. So this is the syllabus that the student is going to learn in the entire curriculum. So module 1 is going to be related to branches of geology using useful to civil engineering, scope of geological studies in various civil engineering projects, departments dealing with this subject in India and their scope, mineralogy, mineral origin, composition, physical properties, minerals, susceptibility of minerals, alteration, basic and optical mineralogy, SCM XRD, scanning electron microscope, X-ray diffraction, rock forming minerals, megascopic identification of common primary and secondary minerals. So these are the various topics that we are going to see in the module 1. And the second part is basically petrology, which is of study of rocks, rock forming process, specific gravity of rocks, ternary diagram, igneous petrology, volcanic phenomenon and different materials ejected by the volcanoes, types of volcanic eruption, concepts of hot spring and geysers, characteristics of different types of magma, division of rock on the basis of depth of formation and their characteristics, chemical and mineralogical composition, texture and its types, various forms of rocks, IUGS classification of panatric and the volcanic rocks. In addition to this, there is some additional material related to petrology. So the field classification charts, structures, classification of igneous rocks, the basis of chemical composition, detailed study of acidic igneous rocks like granite, rhyolite, tuff, felsite, pegmatite, hornfels. The type of rocks like metamorphic, oral, colonization, landform as stars, engineering aspects of to granite, basic igneous rocks like gabbro, dolerite, basalt, engineering aspect to basalt, sedimentary, etc. And classification of sedimentary rocks and their characteristics, detailed study of conglomerate, breccia, sandstone, mudstone, shale, limestone, petrology agents and their types of the metamorphism and metamorphic grade, mineralogical composition, etc. Structures and texture in the metamorphic rocks, important distinguishing features of rocks as cleavage, stoichionicity, foliation, classification, detailed study of genesis, schist, slate with engineering consideration. Additionally, the physical geology and rock mechanics, weathering, erosion, denudation, factoring affects the weathering and the product of weathering engineering condition, superficial deposits and its geotechnical importance, waterfall and gorges, river, meandering and alluvium, glaciers deposits, laterite, etc. So landform loess, residual deposits of clay with films, solidification deposits, mud flows, coastal deposits, subsurface investigations in rocks and engineering characteristics of rocks, rock masses, structural geology of rocks, classification of rocks, field and laboratory testing on rocks, stress deformation of rocks, failure theories and shear strength of rocks, bearing capacity of rocks, etc. So coming to the module 4, geological hazards, rock instability and slope movements, concept of sliding block, different controlling factors, instability in vertical rock structures, measures to prevent collapse, types of landslides, prevention by surface drainage, reinforcement by rock bolting and rock anchoring, retaining walls, slope treatment, case study on black clay, groundwater, and the factor controlling the bearing capacity of rock. And module 4 continued. Pervious and impervious rocks, groundwater, lowering of water table and subsidence, earthquake, magnitude and intensity of earthquake, seismic sea waves, revelation for seismic records of structure of earth, case study on evaluation and subsidence of Himalayan region in India, seismic zones in India, geology of dam and reservoir site, required geological consideration for selecting dam and reservoir site, failure of reservoir, favorable and unfavorable conditions in different types of rocks in presence of various structural features, precautions to be taken while counteracting the unsuitable conditions, significance of discontinuous on the dam site, and treatment given to the such structures. So these are the mostly dedicated books for engineering geology. Chennakeshavulu, which is engineering geology, where most of the syllabus, like 70% of the syllabus, is been covered. So particularly for the petrology part, one can look at FG Bell, which is the fundamentals of engineering geology, where you found it more worth reading the book. And also like KVGK Gokale, principles of engineering geology. Now coming to the start of this topic. So before that, we need to understand what is engineering. So the application of science and mathematics by which the properties of matter and the sources of energy in nature are made useful to people. Geology, the science which deals with physical structure and substance of earth and their history and the process which act on them. Geology in Greek means geo means earth, logos means science. So the study of science of earth is nothing but geology, and which is the branch of science dealing with the study of earth, and it is also known as earth science. So the study of earth comprises of whole earth and its origin, structure and composition and history and the nature of the process. So we will see the one more definition of engineering geology. Engineering geology has been simply defined as application of geology to engineering practice. In other words, it is concerned with those geological factors which influence the location, design, construction, and maintenance of engineering works. So, understanding geology and geological principles is vital to practice of geotechnical engineer and civil engineering practice. Failure to appreciate the geological context in which infrastructure is developed has led to catastrophic failure and loss of life and property. So these are the few iconic examples of geological structure, and how we can see that the type of formation of different types of geological examples. Additionally, now we are going to see a case study which is at Washington. So the name of the slide is Oso Landslide, where this is the flowing river, where the river was flowing in this pattern. So in the year March 2014, March 2022 2014, 43 people were killed and 49 structures were destroyed. So we can see there is some residence here. So this is the slope outside the river, bent and actively eroding toe. So we can see here from the previous slide, we can see that there is some sliding which is happening slowly or gradually. There is no greenery, that way we can also assume. And then we can see here the area of the slide origination. Note uh, color difference of vegetation and bare earth on left side. So Steel Haven neighborhood, which is present here, this is the Steel Haven neighborhood. So later, this particular toe, which we were highlighting here, can be clearly seen that the entire slope has been washed away. So if you see the real-time picture, so this is the washing away of the sample away from the river. Later, so this is the graphical image of the wash away of the sample. So these are the effects. Was this a completely unforeseeable event? Like how could a better understanding of geology and engineering geology principles have? So improved planning and policy making, influenced development in this area, informed property owners of risk, saved lives and protected infrastructure. So other examples of mismatching geology and infrastructure are home built on eroding sea cliffs, shallow foundation built on consolidating soils, and unreinforced masonry structures in seismic zones, chalets in avalanche chutes, road cuts into the toe of the old landslides, straightening of streams and rivers of bridges and culvert crossing, and clear vegetative cover over permafrost for construction, trapping groundwater behind retaining wall, etc., and many more. So these are the various branches of geology. One every student must have a clear knowledge, which is physical geology, petrology, mineralogy, paleontology, historical geology, mining geology, structural geology, and stratigraphy. So coming to first the physical geology, which is also called as dynamic geology or geomorphology. Physical geology deals with different physical features of the earth such as mountain, rivers, glaciers, and volcanoes. It also deals with different changes occur in the earth's surface, like foundation, formation and disappearance of rivers, springs, lakes, etc. And physical geology includes the study of erosion, transposition, and deposition. Petrology is the study of rocks, where I have already informed during the syllabus discussion, where petro is rock and logos is the study. Petrology defined with study of rocks. The earth crust is also called lithosphere and is made to different types of rocks. Petrology deals with the different formation of structure, texture, composition, occurrence types, etc. A rock is defined as the cluster or combination of minerals found in the earth crust. The study of petrology is more important for civil engineer in the selection of suitable rocks for building stones, road metals, etc. So this is the structure of the earth: lithosphere, essentosphere, lower mantle, outer core, inner core, mantle, crust, etc. So this is what we were studying long from since long, and this is the total shape of the earth, where the individual depth has been given with the different types of technical names. Now again we can see the examples of the rocks. Now coming to the mineralogy, this is the branch of geology deals with study of minerals. A mineral may be defined as naturally occurring homogeneous solid, inorganically formed and having a definite chemical composition and order arrangement. So these are the various types of minerals. There are thousands of minerals that are available in the nature. Next comes to the paleontology. A branch of geology deals with the study of fossils and their ancient remains. If under favorable condition, animals and plants life gets embedded in sediments, it will be preserved partly or completely. Such remnants is ancient life preserved in rocks by natural process are known as fossils. Historical geology, which deals with the study of stratigraphy and the paleontology. Mining geology, that mostly the mining is done in the rock samples or in the solid excavation is needed, etc. So like to understand the subsurface profile by the uh, by by the excavation, etc. So this is the profile where I can say that this is the some coal mine where lot of the coal is being getting disappeared from this particular place. So what is regarding structural geology? It is a branch of geology deals with study of structures found in rocks. So it is also known as tectonic geology. So most of the geology we are mostly keep on emphasizing on this structural geology part, where the rocks which forms the earth crust undergoes various deformation, dislocation, and disturbances. That is what where we were looking at the igneous rock, metamorphic rock, sedimentary rock, etc. So the results of the occurrence and of geological structures like folds, faults of rocks, etc. So the detailed mode of formation, causes, types of classification, and their importance, etc. And structural geology is an arrangement of rocks and plays an important role in civil engineering in selection of suitable sites for all types of projects such as dams, tunnels, multi-story buildings, etc. So this is the example of structural geology, where we will be learning more in detail in the upcoming slides. So this is the stratigraphy of the formation, which again we will see more in detail in the upcoming classes. So we will be meeting in the next lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.